Hey guys, so today we are going to review for the first test. And while this might not be like the best way, it's actually going to be a more thorough way because I'm going to just work the practice test with you. And so you'll get to see one of every type of problem that will come up on your actual test. Now, if you pull up your practice test while we're doing this, your numbers will be slightly different because that's the point. Everybody pulls up their own practice tests. They all have the same kind of problems. They just might have slightly different numbers. However, this will be a great way for you to review to get ready for your first test. So I'm going to screen share my practice test with you guys so you can see the problems that I will be working. Maybe. Where is it? Stop that share. I don't know why it didn't pull up. Let me make sure mine's open. It's open, it's ready. Okay. Let me screen share again, sorry. Screen sharing the problems. There we go. Okay, so I'm just going to work through the problems, and that way you can see a little bit of how the test will work. So you pull up the practice test, it tells you how many points are possible. That tells you you're going to have 27 questions. And so this is my first question. So I'm just going to go from like straight through, and hopefully this will be a good review for you guys, okay? So number 1 says use factoring to solve the quadratic equation, or you can use a graphing utility and identify the x-intercepts. I like to just use the factoring, and I'm going to do it the old school method. So the old school method is where I start like this, and then I have x squared, so I know I'm going to have x and x. I have a minus here, so that tells me I'm going to have a minus and a plus, because there's no other way to get a minus there without a minus and a plus. And then I need to ask myself, what are the factors of 48? Well, the factors of 48 are 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So there's lots of factors of 48, but I need to ask myself, if I subtract 2 of the factors, is there one that'll give me a 2 or a minus 2 as my middle? So if I subtract 48 and 1, am I going to get 2? No. 24 and 2? No. 16 and 3? No. 12 and 14? No. But if I subtract 8 and 6, I do get a 2. So then I look here. Is that a positive or a negative? It's a negative, so that tells me that I need to have more negatives than I do positives. So then I have x minus 8 equals 0, so x equals a positive 8. I also have x plus 6 equals 0, so x equals a negative 6. So then on your test, it says solution set, and then you just type in the numbers, negative 6, comma 8. It says you separate them by commas if you need to. Go on to the next problem. This time it says, I hate that previous question thing is lingering. It says solve the equation using the square root property. So the square root property is where we have a square on one side, and so we're square root both sides in order to get rid of the square. So we have 4x squared plus 1 equals 41. Now we do have an x squared, but it's not by itself yet, so don't square root yet. We got to get everything else moved over. So the first thing I do is I'm going to subtract 1 from both sides. That gives me 40. I still don't have my x squared by itself, so I'm going to divide both sides by 4. That gives me x squared equals 10. Now the x squared is all by itself, so now I'm going to square root both sides to cancel out that square. And I get x equals, now here's the part you can't forget. when you're doing a square root, you have a plus and a minus. So it's not just the square root of 10, it's going to be positive square root of 10 or negative square root of 10. Notice again that there is little blue words under your answers, and that helps you to know how to type it in. It says type the exact answer, so it doesn't want a decimal representation of the square root of 10, using the radical, and use commas to separate. So it doesn't want you to put plus or minus. It wants you to have square root of 10, comma, square root, or negative square root of 10. So negative square roots 10, and then make sure, notice when I'm under the radical, my number is blue. So if I put my comma now, it's going to be under the radical. So push to the right and make sure you're outside of your radical. Put a comma, and then square root 10 again. Notice that when you're doing a test, it's not going to tell you if you're right or wrong until after you submit at the very end. And so you always have the option to go back and correct a problem or go back and work a problem that you maybe will skip. So don't forget to do that, okay? All right. The next one says use graphs to find the set. So we have -4, 4, union -1, 5. Okay, so remember union, that's with our Venn diagrams. A union of like A and B would be everything in A and everything in B. Okay, so if we're doing this on a number line, let's see, when you go -4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Okay, so here's our number line. Our first one says -4 to +4, and those are with parentheses. So it's all of that. We're going to union that with -1, using brackets, all the way to +5. Now, union means we take everything from the first set and everything from the second set. So if you graph this on a number line, really what you're looking at then is the end pieces. You're looking at how far to the left do I go and how far to the right do I go, and that is your new interval. So we go as far left as -4, but not including -4. And then we go all the way to +5, but we do include +5. And so that is our new interval. Says the set is, and fill in the answer with your choice. It says interval notation, which is what we have put there. So parentheses, -4, 5, and then above your like return or enter key should be where your little bracket is, and you don't have to shift or anything for it. Okay, here's our word problem, first one. I told you word problems will come up on the test. The word problems also come up on the midterm, and they come up on the final. So we got to get used to midterms, or word problems, excuse me. I wish I could get rid of, there, it went away. Let me make my window down here though, so you can see all the words. So it says the bus fare in the city is $2. So I'm going to say fare equals $2. People who use the bus have the option to purchase a monthly coupon for $25. So then we have the monthly, which is $25. With that coupon book, the fare is reduced to $1. So you have to pay $25 for the coupon book, but then the fare goes down to $1 every time you ride the bus. I don't like how that looks right now, but I'll show you in a minute. Determine the number of times a month that the bus must be used so that the total monthly cost without the coupon book is the same as with. So this is exactly like the problem from your notes where it was crossing a bridge. So we need to know how many times we can use just the fare versus how many times we use the coupon book and the fare in order for them to be the same. So the fare is 2 times every single time we ride the bus, but we don't know how many times, so I'm putting an X. The same thing is true for a coupon book. It's $25, but then it's $1 every single time we ride the bus. So now we want to know if our fare and our monthly are the same, how many rides is that? So I'm just going to set my monthly, or my fare, which was 2X, equal to my monthly. Notice I dropped the 0.00 for the money, and I dropped the $sign. That way it's more mathy. But now I just solve for X. I'm going to subtract X from both sides, so I get X equals 25. There's nothing else to do. So 25 times I can take the bus in the monthly discount book, and just using regular fare system is going to cost the same. Okay, this is complex numbers. This was 1.4. So we had 8 minus 3i, 4 minus 2i, and this is multiplying complex numbers. When we do this, we're using the FOIL method. So we're going to do first, which is 32. We do outer, which is negative 16i. We do inner, which is minus 12i. And then we do last. A negative 3 and a negative 2 is a positive 6, and then I squared. So 32 minus 28i, I just combine these two. And then 6i squared, remembering that I squared is negative 1, becomes a negative 6. So 32 take away 6 is 26 minus 28i. Remember, you typically put the real portion of a complex number first, then the imaginary portion. So that was 26 minus 28i. All right. Solving rational equations. Rational equations are fractions, or equations that have fractions in them. They look scarier than they are, so don't let it overwhelm you. X over 2 equals 2 plus x minus 25 over 5. So there's really 2 different ways you could do this. We could get a common denominator for everything. That way it would all simplify and reduce out. Or you can think of what would the common denominator be. What are the denominators right now? We have 2, that's a whole number, so you can think of it like 2 over 1, so that's 1 and 5. So the common denominator that we would be getting is 10, because 2 goes into 10, and 5 goes into 10, and 1 goes into 10. So instead of making everything have that common denominator, you can multiply both sides by 10, and thus we're going to eliminate the fractions entirely, and that's going to be really nice. So over here, I'll write it out. We had 10 times x over 2 equals 10 times 2 plus 10 times x minus 25 over 5. So I'm writing it again so that we can see that 2 and that 10 is going to go away, and I'm left with 5. So that's 5x equals 20 plus that 5 is going to go away, and that 10 is going to reduce down to 2. So it'll be 2 times x minus 25. 5x equals 20 plus, I'm distributing my 2 in, 2x minus 50. Combine like terms, I'm going to subtract that 2 over. 3x equals 20 minus 50 is a minus 30. Divide both sides by 3. And I get x equals a negative 10. You can always go back through and check to make sure that that works. I actually did check it, and it does work. I checked it on my paper to make sure that my math was correct. solve the equation by completing the square. So completing the square is important. It's in 1.5. I will say on this specific problem, I didn't like that they required completing the square because it's much easier just to complete it by factoring. However, I don't always get to pick that. So we will use completing the square so that you see the process for completing the square, because you will have to complete the square on the midterm and the final exam. So we had x squared minus 11x plus 30 equals 0. So remember, when you complete the square, the first thing you want to do is you want to get the c part, or the constant part, over to the other side. And you want to leave this plus blank on both sides as well. So it's minus 30 plus blank. That blank is where our 1/2 b squared part goes. So I always write what my b is, which is -11. Then I say, what is 1/2 b? -11 over 2. And then what is 1/2 b squared? Well, -11 times -11 is 121, and then 2 squared is 4. Now, what goes here in these blanks is our 1/2 b squared portion. So that 121 over 4 is what goes in those blanks. Remember, the whole goal of, and the reason why we do this is because we want to get a perfect square inside of here. And what goes in here is the 1/2 b. But then it's a perfect square. That way we can use the square root property to square root both sides in just a moment. So over here we have a whole number and a fraction. So we have to get a common denominator. The common denominator will be 4. So that's 4 over 4. Sorry, my head's in the way. So -30 times 4 is a -120 all over 4. So we're taking 121 over 4 minus 120 over 4, which is leaving us with 1/4. So the numbers really aren't as bad as they look in the beginning. Now that we have something squared on one side, we can use the square root property to square root both sides to cancel out that square. So we have x minus 11 over 2 equals, and this is where you have to be careful. Just like on the previous problem where we had a square root, if you don't move around enough in the classroom, the lights go off to save energy. If you have a square root, it's a plus or minus. Here's the nice thing. The square root of 1 is 1. The square root of 4 is 2. So we get plus or minus 1/2. So we don't have a nasty radical to deal with the whole time that we're finding our answer, which is nice. So I do need to still add 11/2 to both sides. So I have 11/2 plus or minus 1/2. Well, obviously I need to combine these and subtract these. So over here I have x equals 11/2 plus 1/2. That's 12/2. Well, 12 over 2 reduces down to 6. Or I have x equals 11/2 minus 1/2. Is that all on the screen? Nope. Boop. There we go. So 11 minus 1 is 10/2, which equals 5. So in this case, x equals 5, 6, which you could have factored it at the very beginning because it was a nice quadratic, but they wanted you to complete the square. I guess a word of caution or whatnot. Obviously, I have no idea if you complete the square. If you're doing this at home, I don't demand that you turn in scratch paper or anything like that. So I would have no clue if you did it this way or if you factored it. The only thing I would say is typically if it asks you to complete the square, typically you're not going to get nice numbers like this. you're going to get something that has a radical in it or a really messy fraction. So I would just be very cautious. If it says complete the square, I would recommend completing the square, unless you know for absolute certainty that it's going to be a nice whole number like that. Okay? Remember, if I'm moving too fast, the nice thing about lectures or help on the computer is that you can always pause me to do writing or whatever you would like to do. Another way I recommend using this video is actually to try the problem yourself, like pause before I do the work, and then you can compare your answer with what I have. Okay, so that's the next problem. It says solve the absolute value equation or indicate that the equation has no solution. So remember, there was a special thing with absolute values where you could look at the C value, compare it to 0, and that's going to tell you if there's 2 answers, 1 answer, or 0 answers. So the first thing we have to do, though, is we have to make sure we have everything over there besides the absolute value before we can compare. So we're going to subtract, oops, that's supposed to be absolute value. We're going to subtract 9 from both sides, which will give us a -3. Now the rule stated, and if you don't remember, you can go back and look at 1.6 is where we learned it. No, 1.7, I think is where we learned it. Apologies. 1.7. And you can see that if C is less than 0, then that tells us that there are no solutions. The reason for this is, if you remember, the absolute value tells you the distance away from 0. So if we take the absolute value of anything in here, we should get a positive number. So if our C value tells us that it's a negative number, then that tells us that there's no solution. So in this case, our C was -3. So there is no solution, or the solution set is the empty set, meaning there's nothing in the solution set. Okay. (6i minus a -6i). So this is imaginary numbers. However, this is really more about when you have 2 signs side by side and what they mean. If the 2 signs that are side by side are the same, so like 2 negatives or 2 positives, then they become a positive. If they're the opposite signs, then it stays a negative. So a negative and a negative, so that becomes a positive. And then we combine like terms. They both have i's, so we can combine them to get 12i. So for this one, it says solve the linear inequality and then use the interval notation to express the solution to the graph and the graph on the number line. Okay. So we're going to use interval notation for our solution, but then we have to graph it on the number line. All kinds of fun stuff. So the problem says 7 times x plus 1 plus 4 greater than or equal to 6x plus 17. So the first thing we're going to do is we're going to simplify this expression. We're going to use the distributive property here for 7x plus 7 plus 4 greater than or equal to 6x plus 17. Combine like terms. And now I'm going to start moving things over. I'm going to keep my x's positive, so I'm going to subtract 6x over. I'm going to subtract the 11 over. So I get x is greater than or equal to 6. Now that's the set builder way of putting it, and it said it wants the solution in interval notation. Interval notation is where we say, okay, well, how small can this number be? Well, it says x is greater than or equal to 6. So the smallest it can be is 6. And it says equal to, so that means we're going to use a bracket because it could be 6 as well. And then how big can x be? Well, x is any number that's greater than or equal to 6, so it can go on for infinity. Remember, you always use a parenthesis when you are talking about infinity because you can never actually reach it. So that's what our solution set is. So we have bracket 6, comma, and then there's an infinity button and close with parenthesis. And then we have to graph that on our number line. So on our number line, 5, 6, 7, 8, 9, 10, 11. Okay, so on our number line, we know that 6 is included, so that means we're going to use a filled in circle at 6. And then it's anything that's bigger than 6. So on our number line, bigger numbers are to the right. So we're going to go this way, and I'm going to just do a really big arrow since it's white on white and a squiggly to try and show which direction we're going. Filled in circle at 6, going towards the positive side, which if we look down here at our graphs, the only ones going towards the positive side are B and D. But which one is at positive 6? It is B. The other one is at positive 1. And then there was another option for the solution set is 0, or empty, but we found that it's not empty. Okay. We are solving the equation they gave us for a new variable. Notice they use a capital K. That is a capital K. Because they used a capital K, you must type in a capital K or it will count you wrong when you solve this. Now we are solving for D, so we want to get D all by itself. Well, how do we do that? Well, 4 and pi are multiplying D, so we're going to divide both sides by 4 and pi, and that gives us D. So this one wasn't mathematically hard, but you do need to be careful that you use a capital K, and then on bottom, it says be exact, so use 4, and then they give you a pi symbol. If you use a lowercase k there, it will count it wrong. And every semester, I warn students of that, and they do it wrong. I will say the tricky thing that they do sometimes is they'll give you a capital S, and sometimes that's hard to differentiate if it's a capital S or a lowercase s. And so here's what I always say to do. Look at the equal sign. If it goes above the equal sign, like this K goes way above the equal sign, that tells you it's a capital. A lowercase s is going to be there at the same size as this pi symbol. So it is pretty noticeable if it is an uppercase or lowercase s. However, I have students miss it every single year. So just watch the capitalization on that so that you don't miss a point, an easy point. All right, move me back down. Here is our investment one. This one is exactly like the grandma one that I did in class, where grandma needs to invest money, only this time it is Susan needs to invest money. So before we start, remember that interest equals the principal times the rate times the time. That's the general equation. Here we say that Susan needs to invest part of her money, over $35,000, into a fund at 12% profit and at a stock, at a 4% loss. Ooh, I read that wrong earlier when I did my math. Ooh, I'm glad I caught that. So that's a 4% loss. That's kind of important to note. So find the amount of each investment that she's investing if her total profit is $29.20. So that means we have our interest from our 12%, and we have our interest from our 4%, and that's going to give us our $29.20. But here's the word that I missed actually when I was doing this earlier, is it said that the 4% investment actually has a loss. That means we are losing money on that 4% investment. So instead of adding these two together to get the $29.20, whoops, like that, which is what we did with the grandma one, we are actually going to subtract because we're losing the money from here, which means I'm going to have to do the math as we go through this problem, which is totally fine. Okay, so that's only part of it. So here's the thing that you can do. You can either say we have $35,000 and we're investing X and Y at the different ones. That's totally fine. Or you can think about it like this. We have 12%, and at 12%, we don't know what it is. And at 4%, we also don't know what it is. But we know that it's going to be $35,000 minus whatever we invested at the 12. No matter if you think about it in X and Y, or if you think about it like this, you're going to get to the 35,000 minus X because you'd have to solve. So it's just really how your brain kind of works with that. So the interest at 12% is PRT. Well, it's after a year, so our T kind of goes away. So it's just P and R. So our P was X, and our R is the 12%. Then we're going to have a minus because we're losing money on our investment here at 4%. So our principal there is the 35,000, take away the X. And our interest is our rate is 0.04. And all of that equals the 2920. $0.12x minus, I'm going to distribute that 4 into both. So 35,000 times 0.04 is 1,400. And we have a minus and a minus, so it's going to make that a positive. 0.04x equals 2920. So 12x plus 0.04x, so it's 0.16x. And I'm going to add that 1,400 over to the 2920, which will give me 4320. And this is where your nice little calculator comes in handy. 4320 divided by 0.16 x equals 27,000. So then you have to remember what was x? What does that even tell us? X was the amount we invested at 12%. So we're investing $27,000 at 12%. And then the 4% was the 27,000 taking away from the 35,000, which gives us 8,000 at the 4%. So we invested 27, 1, 2, 3, and we invested 8, 1, 2, 3 at the stock. So the only tricky thing there, and it tricked me up. I mean, I worked out all these problems on paper before, and I didn't pay attention that it said loss. And so if it says loss, then you're doing a subtraction. If it says combined interest, then you're doing addition. So you do have to watch for that on those word problems. Okay, I'm going to move me down again because I'm going to make this a bigger picture. Can I make it bigger? I can. Okay. So there's the next problem. It wants us to find the x and y intercepts of the graph given, if there are any. So remember, x-intercepts, that's where it crosses the x-axis, or it touches. And they're always of the form with the x value 0. And the y is the same thing, it's where it crosses the y, or touches the y-axis. And it's always of the form 0, y. So when you're looking at your graph, it's always very nice. I will tell you that. They're always going to give you nice numbers. I usually just start on the left and I follow my graph until I cross my x-axis or I touch it. So I hit it right there at -2, 0. And then I go up and then it starts to come back down. Oh, there's my y-axis though, right there at 0, 8. Oh no, I'm gonna sneeze. Oh, excuse me. I would say the masks, while I don't like wearing them, they do help keep the chalk dust at bay. Okay, so I'm still right here, going. Now, I don't cross the x-axis here, but I do touch the x-axis right there at 2, 0. So that is still an x-intercept because it does intersect with that part of the line. And I go on and I don't cross anymore. So the first question is, what are the x-intercepts? Well, I found one and it says, type the integer as a simplified fraction, use comma to separate them. So I just need to type -2, 2. It doesn't say type it as an ordered pair. It just says type what they are. And then my y was at 8. I gotta move so I can click next. Okay, here's another rational problem. This one though has the x on the bottom, and so it can cause problems for us. Remember, you never want to have a 0 on bottom, so there are certain values when you're dealing with rational equations that x cannot equal. So the very first step it wants you to do is it wants you to identify the value or the values that would make the denominator 0. So what you do there is you look at your denominator, which was x plus 3, and we set that equal to 0. X equals -3 is our problem point. So that's what would make the denominator 0. So we say x equals -3 is our problem point. And then we need to actually solve and figure out what our solution is. So in the last rational one we did, we just multiplied by the common denominator and that got rid of our bottoms. However, we can't do that if our variable is in the bottom. We actually need to get a common denominator for everything. Luckily, we have x plus 3 and x plus 3. So 2 of them already have the same denominator. The only one that doesn't, stupid light. The only one that doesn't is the 7. So I just need to multiply the 7 by x plus 3 and x plus 3. So I'm not going to do anything to the rest of the problem. I just have 7, and then I need it to get an x plus 3. But what I do on bottom, I have to do on top. Remember, 7 is the same thing as 7 over 1 minus 6 over x plus 3. The reason why we do this is because once they all have the same denominator, you can just ignore it. Now you have 2x equals, I'm going to take 7 times x and 7 times the positive 3, 7x plus 21 minus 6. 2x equals 7x plus 15. Subtract my 7x over, I get minus 5x equals 15. So x equals a -3. So then we've solved it, but when you're dealing with rational equations, you have to compare your solution to the problem points. What was our problem point at the very beginning? The problem point was x minus 3, or x equals -3. And what solution did we get? X equals -3. That means it's not a real solution, it's an extraneous solution. And that means, since that was our only solution, that there actually is no solution for this one. So our solution set would be the empty set or the null set, because the only answer that works mathematically gives us a 0 in the denominator, which we can't have. And so you do always want to check that. Solve the radical equation. We have square root of x minus 2x equals x. So to do these, You want to get rid of the square root, and the way to do that is you square it. But you have to square everything. So you're squaring both sides, which causes that to go away. So you're left with 8 minus 2x equals x squared. Now I'm going to move everything over to the right-hand side so that I have a nice quadratic. That means I added my 2x and I subtracted my 8. Now I would factor. You can use any method you like. I like the old school method. So there's an x squared, so I have x and x. That's a minus, so I know I have a minus and a plus. Excuse me. And then I'm thinking of factors of 8. Well, luckily there's only 1 and 8 and 2 and 4, but I need them to subtract to give me a 2. So it's going to be 2 and 4. There's positive 2, so that means I need a positive 4 and a minus 2. So x minus 2 equals 0, x equals 2, x plus 4 equals 0, x equals a minus 4. Now, when you're dealing with a radical, though, we do have to check both of our solutions to make sure that they both work, because they can give us incorrect solutions. So I'm going to check x equals 2. So 8 minus 2 times 2 equals 2. All I did is anywhere in the original problem that there was an x, I'm plugging in 2. 8 minus 4 equals 2. Square root of 4 equals 2. 2 equals 2. So that one worked. So we officially know that x equals 2. Now we'll try x equals negative 4. 8 minus 2 times a negative 4 equals a negative 4. Square root, we have 8. Negative 2 times negative 4 is a positive 8. Whoops, I don't know what I'm doing. Square root of 16 equals negative 4. 4 equals negative 4. That's not correct. So x equals negative 4 is an extraneous solution. So our only solution is 2. That's why you always have to check. That way you know you don't have an extraneous solution. All right, another graphing one. Graphing with a number line at least. We have negative 6, comma 1, intersect negative 1, comma 6. So remember, intersection is where you have two sets, and the intersection is what do they have in common. So using a number line, negative 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. And if you can do this without a number line, that's totally fine as well. A lot of people are very visual learners, so I like to do the number line. And it said to use a graph, and this is how you graph them. So again, just like with the last one with the union, I would graph both of these. So I start at negative 6, and I'd have parenthesis, and it goes all the way to positive 1. And then it's intersecting with this other one from negative 1 all the way up to positive 6. Now, when you did union, we were combining both of those and using all of the points. So we looked at the extremities. However, when you're using intersection, you just want to know where they have stuff in common. So where do they intersect? Well, they only intersect right there in the middle from negative 1 to 1. And so that is our interval. And it says use interval notation from bracket negative 1, comma 1. Notice that we still only use a parenthesis here, even though that's included in the bracketed side here, because it's not included here. And so we need it to fit both of the rules, and that's how you'd have to leave it. Okay. I'll do couple more, and then probably have to put a pause in the video and then continue after class. Okay, next one, it says compute the discriminant. So we have 6x squared minus 6x plus 6 equals 0. Lots and lots and lots of sixes. So remember from 1.5, the discriminant tells us what's going on in our graph. It tells us if we have two real solutions or that are unequal, we have one real solution, or if we have no solutions and two imaginary solutions, or if there's infinite number of solutions. Our discriminant tells us all of that. And the discriminant was the b squared minus 4ac. It was what was under the radical part of the quadratic equation. So when you need to find the discriminant, I always find my a, my b, and my c first. So my a is 6, my b is -6, and my c is 6. And then I plug them in. So I have -6 squared minus 4 times a times c. That's 36 minus 144. And so that's a minus 108. And then from 1.5, if your discriminant is less than 0, that tells you that there is no real solutions, but there are two imaginary solutions. So what was the discriminant? We have to type that in. We found that the discriminant was negative 108. Oops, not 107, 108. And that out of these four options, there are two imaginary solutions for that. Alrighty. Next problem. 8x to the 4th minus 32x squared equals 0. This is factor to solve the polynomial. So when you're factoring with a polynomial, what you're doing is you're asking, what do these two things have in common that I can pull out? So what does 8x to the 4th minus 32x squared have in common? Well, the first thing I would look at is the numbers, 8 and 32. Well, 32 is 8 times 4. So I know I can pull out an 8, and then I look at my variables, x to the 4th and x squared. I know I can pull out x squared. So that's going to leave me in this first one with just an x squared, and it leaves me with the second one with just a minus 4. When you are doing these problems, you typically know that you've done them correctly if you get a difference of squares here. That's kind of the goal, is to get a difference of squares. So that would be 8x squared, x minus 2, x plus 2 equals 0. So now I set each of these individually equal to 0 to solve for my x's. So 8x squared equals 0, x squared equals 0, x equals 0, x minus 2 equals 0, so x equals 2, x plus 2 equals 0, so x equals a minus 2. So those are my three solutions, 0, -2, and positive 2. 0, -2, comma 2. And it doesn't matter which order you put those in, as long as you have all of them in there. So I am going to pause, and I will do another video here shortly for the other ones. Stop sharing and recording. Hey guys, let's finish up the test one. Hey guys, let's finish up the test one review. I'm going to screen share again my test with you, and then we will finish up. We only had a few more problems left, so we should be able to go through this pretty quickly. Let me make me a little bigger. Okay, so this first problem that we have says we have the absolute value of 2x minus 3 is less than 7. Okay, for absolute values, what you're going to do is we split them. So we write it exactly the same way with an equal sign. And then we write it exactly the same way, again with an equal sign, but instead of having a positive 7, we're going to have a -7. And that's because what's inside of our absolute value can be positive or negative, but when we take the absolute value, it all becomes positive. So in order to find those two values, we have to split it like this. So we add the 3, divide by 2. And then we're going to add the 3 and divide by 2. For some reason. Yep. Okay. Sorry, I was checking my notes. For some reason, that looked a little funny to me. So 5 and -2. Next. Okay. This was the more complicated radical problem that we did in 1.6. Doesn't mean it's hard, it just had a lot more steps to it because you have to eliminate both of the radicals. So you have the radical x plus 9 minus the radical x minus 2, and that equals 1. So typically when you solve radicals, you want to get the radical by itself. But when you have two radicals, what you have to do is you have to split them. That means you need to have one radical on the left side of your equal sign and one radical on your right. So I'm going to add this radical x minus 2 over to the other side and isolate the x plus 9. Once I do that, in order to get rid of my radical on the left, I'm going to square both sides, because when you square a radical, it goes away. So I'm left with just what's under the radical, which is the x plus 9. And then on the right, I have everything that was over there, quantity squared. So I'm going to have two binomials that I need to multiply together. And when you multiply binomials together, the way you do that is you use your foiling method. So we do our first, we have the square root of x minus 2 times the square root of x minus 2. That means we have the square root of x minus 2 squared. So once again, we just have the x minus 2. Then you do your outer, so it's plus the square root of x minus 2. You do your inner, plus the square root of x minus 2. And your last, which is this plus 1. Now I'm going to combine my like terms that I have on my right side. -2 plus 1 will be a -1. And then I have two of these square roots of x minus 2. Now I just have one radical, so I need to isolate it. I have to get it by itself. So I'm going to subtract over my x and my 1. When I subtract over my x's go away. When I add over my 1, I just get 10. 10 equals 2 square roots of x minus 2. At that point, I can divide both sides by 2. So I get 5 equals the square root of x minus 2. And then once again, to get rid of the radical, I'm going to square both sides. That will give me 25 equals x minus 2. Add the 2 over, so I get 27 equals x. Remember, with a radical, you always want to plug it back into the original and check to make sure it works. I have checked it for you. It does work, so that one is correct, and you're okay to have that. But in general, you want to check it because you remember you don't want to get a negative under your radical. That gives us those pesky imaginary numbers, and we don't want to have those. Okay. now we have a rectangular problem. We're going to find the length of, I think it's a football field. My back is to it, so I'm not sure. Length of a new rectangular playing field. Okay, so it says the playing field, the length of it. So let's draw a picture. Remember, we have width, we have length. So the length is, so if you see is, you can automatically write equals 7 yards longer. So 7 yards longer than what? Double the width. If the perimeter of the rectangular playing field is 314 yards, then find the dimensions of the playing field. So you have to remember that perimeter of a rectangular shape is 2 length plus 2 width. Once you know that, we can plug in the values that we do know. So we know that it was 314 for our P. We know 2, and then we need times our L. Well, our L is 7 plus the 2W. So I'm going to write that instead of L. And then I still have my 2 widths on the end. Now I'll distribute. So I have 314 equals 14 plus 4W plus 2W. I'm going to subtract my 14 over, combine my W's, divide both sides by 6, and I get my width is 50. From there, I can plug that in up here to discover what my length is. My length was 7 plus 2 times my width, which equals 7 plus 100, which equals 107. So the width, you got to make sure you get it in the right box. Our width was 50, and our length was 107. And you can always go back and check this by plugging it into the perimeter equation. Plug in what we got for L and plug in what we got for W, and it should equal the 314 that they told us in the beginning. All right, let me move this up a little bit. We're going to express the interval in step builder notation and then graph it on the number line. So this is all from 1.7. So we have the interval is 0 to infinity. So we need to solve that as step builder notation first. So what we are asking is how to do that. So maybe it's easier to look at it on the number line first, even though they're asking for the step builder. So if I have a number line, 0's in the middle, and I have 1, 2, 3, and so on, and -1, -2, -3. Well, my values for x are 0 to infinity, and it's a parenthesis, which means I'm not including 0. So at 0, I can put, oh, I got colored chalk for this. I can put, ooh, scratch. I can put a parenthesis right there at 0. And then I'm going towards the positive infinity. I'm going like that. So that's the graph. Just from the interval, I'm able to draw that graph. And now I need to take it to an inequality. I need to get my step builder notation. So how do I represent that as a step builder? Well, what do I know? I know my x has to be greater than 0. Now, when you say it out loud as you look at it, then that kind of tells you what you're going to write. I just said x has to be greater than 0. Well, that's an inequality. If I stick the such that x inside the curly brackets around it, there's my step builder. The nice thing is they give you the curly brackets and the x such that. So here we just click and we say x is greater than 0. And then we look at our graph. That's at 0, but it's going the wrong way. That's going everywhere. There's 0 going towards the positive, so I'm going to select E. Okay. Again, this is from 1.7. This is a compound inequality. And remember, there are 2 ways that you can do a compound inequality. You can split it, or you can think about doing the same thing to all three sides. I usually think about it as the same thing on all three sides. So I look at my middle, I need to get x by itself, and I have that minus, or that plus 2. So I'm going to minus 2 from every side. That'll give me 3 is less than x is less than 5. That's it. That's all I can do. Now it says though that I need to write the solution in interval notation. Okay, well these are both less than, so it's not equal to, so I know I have parentheses on both sides. My low point is 3 and my high point is 5. So it's 3, 5. Good old imaginary numbers again. We have 7, making sure it's the same numbers, yeah. 7i minus, and then parentheses 15 minus 4i. So when you're given a problem like this, we need to combine like terms, but before we can do that, we have this negative outside the parenthesis. So you treat that like a -1 that you're multiplying everything by inside. So you have to distribute that in. So I have 7i minus 15 plus 4i. And then remember, you usually write your real stuff first, so the minus 15, and then I have 7i plus 4i, that's 11i. So I have negative 15 plus 11i. I can't combine those any further because the 15 is real and the 11 is not. Write the absolute value of 10. Hopefully I don't need to go to the board for this. Well, what values of x can give you the absolute value of 10? Well, you can have 10. You can also have negative 10, because both of those are 10 units away from 0, and that's what the absolute value is. Solve using the quadratic formula. So this specifically tells us to use the quadratic formula. 2x squared minus 15x minus 1 equals 0. So remember the quadratic formula? I sang it. It's goes to pop goes the weasel. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So the first thing I do on these is I say a equals 2, b equals a negative 15, and c equals a negative 1. And then I'm going to plug those in to my quadratic equation. So I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative and negative makes it a positive 15 plus or minus. Negative 15 squared is 225. Then we have a negative 4 and a positive 2 and a negative 1. So that'll give me a positive 8 all over 4. So I have 15 plus or minus the square root of 233 all over 4. And to the best of my knowledge, that cannot be reduced any further. Simplify your answer, type the exact answer using radicals and i's as needed. So I have, let's see, does it specify? Generally, they don't love the plus or minus, but since they give us the plus or minus, I'm going to use the plus or minus. Oops, sorry, I'm not clicked there. 15 plus or minus the square root of 233 all over 4. Whoops. All over 4. Next. Last one. We need to graph the equation of absolute value of x minus 4. And so they give us a table that they want us to fill out. So we have y equals the absolute value of x minus 4. And it gives us our x. And I'm going to put the equation in here as well, just so you can see the work in order to get to the y values. So it has us do -3, -2, -1, 0, 1, 2, and 3. Those are all the values they want us to know and plug in before we figure out which of these is the graph. Okay, so if x is -3, we have the absolute value of -3 minus 4. Well, the absolute value of -3 is a +3. So you have 3 minus 4, which is -1. You're going to do the exact same process for each of these. So 2 minus 4 is -2. 1 minus 4 is -3. Absolute value of 0 minus 4 equals 0 minus 4. Absolute value of 1 minus 4 equals 1 minus 4. So at that point right there, notice the absolute value of the positive numbers is going to give us the same as the absolute value of the negative numbers. So you should be able to logically just complete the graph or complete your units that way, to where you don't have to mathematically do this middle part for the last two. So I have -1, -2, -3, -4, -3, -2, -1. Okay, so if I'm graphing that, then I need to figure out what that looks like over here. Hopefully you remember that these are always going to look like a V of some kind, either an upward V or a downward V. So immediately you should be able to get rid of B. Now I know at when x is -3, I need to be at when x is at -3, I need to be at -1. So if I'm looking at my A graph, at -3, is that at -1? No. So I know it's not going to be A. So let's look at C. When I go over to 3, am I down at -1? No, I'm down quite a bit further. So let's check D. When I'm at -3, am I down 1? Yeah. -2, 2, -1, -3, 0, -4. Oh, I think we found it. So it's this one. So you click that. Okay. So that is the practice test. There are 27 questions on the practice test. That means there's 27 questions on the actual test. I literally create the practice test and then I copy the practice test over for the actual test. So it's not any different. The only thing that's going to happen is it'll give you slightly different numbers. So like this last problem, instead of the absolute value of x minus 4, it may be the absolute value of x minus 3 or the absolute value of x plus 1. It's going to be the exact same process in order to get the solutions. It's just different numbers. So I really strongly recommend taking the practice test. I know you kind of just did with me, but I recommend taking your own practice test and working through it. That way you get a good feel for what it is. And that will also show you where you're struggling, which problems are tripping you up. You can give yourself a little bit more time then to get them done. And then I also gave you a whole extra week to get the test done because the review is virtual and there's no classes on Monday. And so I wanted to make sure you guys have time to ask questions. So that is it. I hope you guys have a good time studying.